you've got a clock and you've got an hour hand. So you've got the long hand and the hour hand, right? The point is there's a ceiling, which lucky you were on the right track before as well. So you've got a ceiling and you're asking the distance between the hour hand and the ceiling is what happens as the hour hand rotates. Okay? So as the hour hand rotates 360 degrees, it will reach. Now you just picture it. You can have the hour hand pointing at 12. Now if it's pointing at 12, the distance from the top of the ceiling to this point is the smallest point that it can get to. Whilst the longest point it'll get to has to be this way. True? When it's pointing that way, it is now the furthest distance away from the ceiling. That's the furthest distance from the ceiling. So when it's at 5, so what we're seeing here is that this is the furthest distance it can be away. It's 5. And then as it rotates back, it gets closer to the actual ceiling. So it becomes 2, then back to 5, then back to 2. So now that we've got a picture of the problem, even if you weren't able to picture that, you can still work out the amplitude from this graph. Amplitude is the height between the middle line to the max or min. How do you find the middle line again? What do you do? Yeah. Middle is found by the average of the max and min. So 5 plus 2 divided by 2. That gives you 7 over 2, which is 3.5. So that tells me the middle line is 3.5. But if that's 3.5, how far is it to get to the maximum or minimum? What's the distance? Yeah, 1.5. So that means the amplitude has to be 1.5 because it's 1.5 either direction. Hands up if you got that idea at least. All right, just a few. But did that make sense of what I was doing there? So I described the situation, but even if you didn't know the situation, you can look at it from the graph. Because you've got the max, you've got the min, the middle has to be in between. In fact, you can even count with your fingers and try to work out what's the middle between 2 and 5. Yeah? So 5 take away 2 is 3, half it, and that would have told you it's 1.5 as well. That's another way to do it. So you should be able to find the amplitude is 1.5, so write that in. Amplitude is equal to 1.5, great. Then it says find the period. Now period just means the cycle. Can you see anywhere in the graph that it starts repeating? You just need to pick 2 points where it starts to replicate. I chose these 2 points. Starting point, how long before it comes back to the same spot again? It goes all the way up, comes all the way back down. That took 12. So my period to do one cycle is every 12. Doesn't that make sense? So that cycle, how long does it take? You just pick any 2 points. It doesn't have to be the starting point. It could have been this one. You could have picked this point. That's halfway between the graph. So that would have been 6. And then this one would have been 18. And then you could have worked it out as well. But why didn't I pick the peaks? Because you have to then calculate 6 and 18. But you didn't have to. You were given 0 to 12. So your period has to equal to 12. The period has to equal to 12. So starting off with that, let's see if we can solve it. What's the formula for the period if it's a sine or a cosine graph? 2 pi and n. So 2 pi divided by something has to equal to 12 because we said the period is 12. It takes 12 units or 12 hours before it repeats its cycle again. So work that one out. What's n equal to? It's a bit of fractions here. 2 pi divided by something equals 12. Pi over 6. For those who don't know, this is similar to Pythagoras' theorem back in year 9 where you can swap these two if you want. I don't like thinking that way, but if that's how you did it back in year 9, you can think of it as 2 pi on 12 equals to n, and therefore pi on 6. If you're wondering why that works, you could have just simply did some algebra times n on both sides. N cancels out. You end up with 2 pi equals 12n. You want to find n, divide both sides by 12, and you end up with the same idea. Yeah, that's the algebraic approach. Why do students struggle with that? Because generally fractions is what scares them. So you should have got pi on 6 as your n. Can I get a show of hands who got pi on 6? All right, it's a bit challenging today, isn't it? All right, it's good. It's good. The point is to challenge you guys. So now we've got the period. Now they told us to find the rule, but they also said the function is a sinusoidal, because I mean, you could have taken it as a cosine as well. I mean, look at this. This looks like a cos graph, but just flipped. So you can take it as cosine. That's why they had to tell you it's a sine function. But if it's a sine function, usually sine starts at the middle. So doesn't it go up and comes back down? That's your sine. But clearly, this graph has shifted to the right by a certain amount, and it's gone up by a certain amount. So now you're going to have to write a general equation to model this problem. So here we go. We know it's a sine graph. So d of t is equal to a, which is the dilation, times sine of the function, n, which is what affects the period, t, plus b, because I don't know if there is a horizontal translation, plus d, because there must be a vertical translation. But in all of these, you actually already know some of the information already. What do you know? Because once you know a, n, b, and d, then you know the equation. What's something you know of these letters that I just wrote? So you got a, n, b, d. What do we know? You know, a is 1.5. Although sometimes they can argue that what if this is a negative sine graph? So you can't always be 100%, but we can model it as this is a positive sine graph that's shifted to the right. You can do that too. Okay, but it could have been an upside down one. But yes, you can say a is 1.5. Whether it's positive or negative, we're not 100% sure yet. What else do we know? N is pi and 6. All right, so we take that. So a is 1.5, n is pi and 6. What else do we know? D is not 2. Why 3.5? Yeah, remember the sine graph. This is the sine graph. If we're taking it as a positive graph, that graph clearly usually starts at 0. So the fact that the middle line is now at 3.5, that must mean I've shifted the graph up at 3.5, right? So D must be 3.5. Now we've got B. How are you going to work out for B? You got most of the letters. You got A, N, and D. You're just missing one letter. What can you do now? Anyone have a clue? Look at the graph. What else can you do? What other information have they given you? Anyone see anything? No clue? Look for any coordinates, because you got t, you just need t and d of t. So as long as you got one of the coordinates, you got so many. 12, 2. So when t equals 12, distance is 2. When t equals 0, distance is 2. 6, 5, 24, 2. There's a lot of points you can choose, right? So if I want to solve for b there, I can actually just say, well, let's sub a point in, and I'll just do the y-intercept. The y-intercept is 0, 2. So when t equals 0, d equals 2. So here, this is your t, this is your d. So sub that into the equation, you will get 2 is equal to 1.5 times sine of pi on 6t plus b, which is what you don't know, plus 3.5. Actually, no, t you do know. We said 0. Which is a nice coordinate I chose, because that if you put t equals 0, it takes away that pi on 6. So 0 times pi on 6 cancels out. This now leaves you with sine of b. So sine of something equals to 1.5 times that plus 3.5. Now you can do a bit of inverse operations. Let's go. Minus 3.5 on both sides. What do you get? What's 2 minus 3.5? You use a calculator too. Minus 1.5. This cancels out to be 0. Now you have negative 1.5 is equal to 1.5 times sine of b. We're almost there. We're trying to find b, so we've got to get rid of that times by 1.5, divide both sides by 1.5. This works out nicely. This now becomes -1 equals sine of b. So b must equal to sine inverse of -1. So sine inverse both sides. Let's go. Use your understanding of exact values. When will sine be -1? Sine is the y value. So what angle will have a y value of -1? Oh my God. Y values. Here's your y-axis. Yeah, you want this point. Y is -1, length of -1. So that's exercise 14E, knowing the exact values. Sine of what will give you -1? That angle is 270 degrees. Or in pi radians, 3 pi on 2. So you have 3 pi on 2 as one possible answer. There's infinitely many possible answers as long as you land in this spot. Okay? So if you want to land back in that spot, well, that's, it could be 3 pi on 2, it could be 5 pi on 2. Oh wait, no, 7 pi on 2. It could be 11 pi on 2. But remember B, you want the graph to move to the left. Oh, sorry, to the right. You want the graph to move to the right because you went up by 3.5 and you needed to move to the right. Right? So you got plus, if you put a plus 3 pi on 2, that actually shifts it to the left. So what you do is then you say minus 3 pi on 2. So one possible equation, d of t is equal to 1.5 sine of pi on 6t minus 3 pi on 2 plus 3.5. If you're unsure, you can test this. Type it in your CAS, see what it looks like. But I'm going to now, I'm just going to finish off this bit here. This is 3 pi on 2. Okay, so we just needed it to be, oh, wait. Oh, actually, it's better, it's negative pi on 2. Sorry, my bad, negative pi on 2. Just because if it's minus, you think of the angle when it's 0, it would be sine of negative pi on 2. Negative pi on 2 is that. Where if I said t is 0 and it's negative 3 pi on 2, it ends up that direction. Because negative goes this way, positive goes the other way. Okay. All right, let's type it into Desmos and see what it looks like. Here we go. I'm going to go to Desmos. Let's see if we're on the right track. Desmos, we've got d of x is equal to 1.5 times sine of pi on 6 times x minus pi on 2 plus 3.5, and we want it between 0 and 24, wasn't it? There we go. There's our graph. Looks quite similar. Let's see if it's all true. We should have a point at 0, 2. I do have that. Do I have the point 5, 6? Or was it not 5, 6? It was 6, 5. Yes, I do. 6, 5. At 12 hours, did I reach back at 2? Yes, I do. They all match. Now remember, mine was only one of the possible equations that you can get. You can get many different ones there. But that shows that this is my graph and that's my equation. But can I get a show of hands who were able to figure out this bit? That was the hardest bit, to find B. Show of hands who was able to find B. Okay, that's how you can do it. Okay, so really it's this last bit to understand the equation. Sine of what angle to give you -1? And we know it is 3 pi on 2, but which ones, when you're putting into the equation, you also needed to move the graph to the right. Because we want up to the right. But alternatively, you guys could have done a cosine graph as well. That would have worked as well. But because they said sinusoidal, we're sticking to what they've given us. All right. Okay, last one should be easy now. So that was the hardest part. Find the equation of the function. I'll give you now 2 minutes. You got the equation. Can you answer the next bit? So here's the equation. Imagine I gave that to you. So if it was a sack, I probably would have said, show that b equals negative pi on 2. Something like that. Okay, so now, can you use this equation with a CAS or your understanding? Can you answer the next question? Let's give you 2 minutes. I'm going to pause the video. I'm trying to get you to think. So think about the problem here. Let's read the question. It says, at what times, when you're doing applications, make sure to highlight keywords. It says times. Okay, so I want to know what time. Okay, you need to tell me a time at some point. I want the distance to be less than 3.5. Well, let's think about it. This is the d-axis. I want the distance to be less than 3.5. So that's currently at 5. 3.5 is the middle line. I'm asking, when will the graph have a distance less than 3.5? So essentially anywhere that's less than the middle line. Here's the region. That's less than 3.5. Any of those points there. That's like 2 to 2.1, 2.5, up to here, maybe 3.4. So all of this is less than 3.5. From here to here, that's less than 3.5. And also, that is less than 3.5. So when I say what time, this is your t-axis. I'm asking, at this point at 3.5, 3.5, 3.5, 3.5, what time at what times? You see, at this point, when it's equal to 3.5, it's between 0 up until this point. What time is that? Now, how do you work out for all of these points that I just drew in? Well, first work out, when does it equal to 3.5 to begin with? When does D actually equal to 3.5? Because that tells me the boundary. That tells me exactly what time I will equal to 3.5. So how do you do it? You're really solving for this. You're solving for what is when D equals 3.5, find time. On your CAS calculator, you can do this. Here we go, let's define it. Have I defined it before? No, I haven't. All right, let's do it. Define d of x is equal to 1.5 times sine of, was it pi over 6 times x minus pi on 2 plus 3.5 between control enter. Given that it's between 0, control less than or equal to, we want it between 0 and 24. Press enter. Okay, so this is our equation, and I'll put in a domain. Domain is between 0 and 24. All right, we want to know when does this function equal to 3.5? So here we go, menu 3, 1, solve. Find out when does this equation, d of x, equal to 3.5. Solve for x, comma x. Okay, so I've defined the function. I'm typing solve d of x equals 3.5. But again, you can do this by hand too. You guys can do this by hand too. I'm just showing you on the CAS point of view. So if you press enter, what numbers do you get? I can press enter, but I want you to press enter and tell me the numbers. You got 3? It should be more than that. We should end up with like, how many points again? 1, 2, 3, 4. There should be 4 different times it comes up. Because there are 4 different times that it will come up as 3.5. So you got one of them. What are the other ones? All right, so you can find the x-intercepts that way. So you can go menu 6, 0. That's to find x-intercepts. Select to the left of where the x-intercept is. Select to where the right of the intercept is. Select once. And then it just tells you. Alternatively, you could have gone back here and I just said solve h of x. Let it equal to 0. So let y equal to 0. Solve for x. You get the same points. So now you can sketch. Part A, you can sketch it now. Let's sketch it. I'm going to do it on my graph too. So you should have 6, 0. What's the amplitude? It's 4. So it should be 0, 4, 6. So at 3. -4, so 9 is over here. 12. Oh, what am I doing? I should do it on the board so you can see. Yeah. I typed in h of x. So you should have got key intercepts 0, 6, 12, 18, 24. Amplitude is 4 and halfway is 3. So 3 is somewhere here. 3, 6. Where's the other ones? Plus 3 is 9. So 9 is down here. 15 is somewhere up here. In between 14 and 16. And then 18, 21. 21's down here. So this is what your graph should look like. Here we go. 1, 2, 3, 4, 5, 6. Oh, damn. There we go. Something like that. I'm a bit off on just the very end there. So far, so good. How are we with our CAS? All right? Just getting the graph. Yeah? So, you've sketched the graph. When was high tide? When do you get high tide? So, this is the middle. This is the mean sea level. Answering the question. Yep. Like that one? I went to menu. Analyze. And then the first one, 0. And what you do is you select the left of where you think the x-intercept is. Don't put exactly where it is. Go left of it, click once. Go to the right of it, click another time. And so between that interval, it'll find you the x-intercepts. Yeah. And if you want to know the maximum, can do the same thing again. Menu, analyze, maximum. So you can then say left of where you think the maximum is, right of where you think the maximum is, and it tells you 3, 4. So that's how I knew. 3, 4, 9, -4. All right, let's answer the question. B, when was high tide? What's considered high tide? Yeah, when it finally reaches top or when it's above the x-axis. So high tide occurs all of these points here. That's high tide. So you can say when t equals to 3, that's at 3, 4. The other one is, go menu, 6, maximum. Left of it, right of it, you get 15, 4. If the question asked for what times, then you would have said 3 a.m. and 3 p.m. In this case, just says when was high tide. I'd probably still say 3 p.m. when t equals 3 and 15. Therefore, 3 a.m. and 3 p.m. Hopefully this problem is a bit easier to answer or understand. So we got 3, 4, and the other one is 15, 4. So that means 3 p.m. and 3 a.m. to be high tide. When was the height of the high tide? Oh, what was the height of the high tide? What's the answer? What's the height of the high tide? 4. Pretty straightforward. High tide, height of 4, above the sea level. So 4 meters above sea level. What was the height of the tide at 8 a.m.? How do you work that one out? Yeah, sub it in. This is asking when t equals 8. Find h of 8. Since you got a CAS, you don't have to do it by hand. You're ready to find it, just sub it in. H of 8. Okay, let's see. H of 8. -2 root 3. Didn't ask for decimals, so leave it as exact values. So -2 root 3 meters. Now E, a boat can only cross the harbor bar when the tide is at least 1 meter above the mean sea level. Okay, so the tide goes up and down. There's a boat that crosses, but the boat can only cross if it's at least 1 meter above the sea level. So I need it to be 1 meter or 2 meters or 3 meters or 4 meters. It can't be less than 1 meter above the sea level in order for the boat to get through. So when they say when, they're asking what times. Very similar to the other problem I just did. See if you can do this one. So the other one I asked less than 3.5. This one is saying at least 1 meter. So where's 1 meter on your graph? Here we go. 1 meter is somewhere here. That's 1 meter. Yeah. Let it equal to 1. Find out the times. Find out when does it equal to 1 meter, these points here. And what region do you want? You want at least 1. So you're looking for this top half and this top half. There you go. Those are the two regions. And then you got to find out the times. At what times will that occur? See if you can do it on your CAS. Let's go. Hopefully after doing the hard one, doing this one feels much easier. It makes more sense. These are your typical textbook questions. Here we go. I'm going to find out when it actually equals. So h of x to equal 1 meter. That occurs, whoops, not h of x, h of t. So t must occur. Let's do it. Solve. When does it equal to 1? Ooh. You've got 0.48 to 5. You got 5.517. And what else do you have? 12.48. And 17.517. Can I get a show of hands who got the same numbers? Good. Remember, you're not getting full marks yet. Why? It's asking for when. It's weird if you came to me and said, when can my boat go through? And I said 0.4825 and 5.517. It doesn't make sense, right? You have to tell them the time. Now the question is, how do you convert these into a time? Because that's what you have to practice getting into when you answer the questions. First thing that's pretty straightforward, 0 must be the 12 a.m. mark. You just don't know the minutes. That's a 5 a.m. mark, but you just don't know the minutes. That's 12 p.m. That's 5 p.m. You need to work out these decimals as minutes. How do you change hours to minutes again? Times by 60. All of these have to times 60 because there's 60 minutes in 1 hour. All of these are in hours. So convert 0.48 into minutes times by 60. This one is 0.517 times by 60. That will tell you the minutes. 0.482 times that by 60. Change it to our minutes. Yeah, closest minute. Yeah. And then 0.517 times 60. Let's see what you get. So you can either have between 12 something. What's 0.4825? 0.4825 times 60. Whoops. That's about 29. So rounding it off, so 12:29 p.m. a.m. to, because remember on the graph, it goes from 12.29 all the way up to this point. That's when it's above 1. So 12:29 a.m. up to the next one is 5:51.7, so 5 something. 0.517 times 60. Oops. Let's do it again. 31, so that's 5:31. That's one of the periods. So you can get the boat across between 12:29 a.m. and 5:31 a.m. The next one, you got 12. Well, actually, it's the same numbers again. So it must be 12:29 p.m. to 5:31 p.m. There you go. That's a proper way to answer the question. But that last bit, very typical of students mucking up because it's already a lot to, get it onto a CAS and getting some answers. But it's not about the answers. We don't care about the numbers. We care about the interpretation. What does it mean? How does it apply? That's a good entry textbook question. The first one was a bit harder, quite a bit harder. Okay. I'm going to stop the video there because that was a long session on applications there, okay?